if you're using Mars, obviously when you turn off Mars, any parts of your code that are using it won't work anymore. So there's a turn it off and wait for it to break approach as well, right? But so I've actually turned off Mars here. So what you'll find is when I run my test harness now, it doesn't work. And unfortunately, the test harness doesn't really give me, the error handler isn't particularly good. I mean, it tells me it was in the login procedure. So what I've done is I've started Visual Studio in debug mode. I can just step through the application to see what bits don't work. So, oh, hold on, there's a breakpoint there. Shouldn't be a breakpoint there. Just working away. There we go. So what we've got is we've got an error generated. So there's a data access library which is calling this safe execute scalar. So it's got a retry kind of wrapper around it. So I can now see the command object. I could put a watch on that to find. Select title from products where prod ID equals. Okay, so I could go looking for that, or I could look at the call stack as well. So see for example this. I can see on the call stack there is this function called get title that took a parameter of the connection, and that reused the same connection. So you see that? There's a second one called get title that doesn't have a connection, and that probably opens its own connection. So you see here that's opening its own connection. That close there, as we're chatting with Erlen, that close isn't actually needed because the using will actually dispose of that. In the latest version of the Visual Studio code analysis, it'll actually throw that up as a warning. If you've done a close inside a using, it'll throw that up as one of those warnings I showed you at the start there. Okay, so the problem is this get title. If we go down the call stack, we can see where it called it. So this is a problem. What we've got is we've got a result set that we're looping through. Okay, so the login has returned 2 result sets. I'm assuming the second result set has got a list of which DVDs the user bought previously, but it hasn't returned the title. So what they've done is they've written a query for every single one to go away and get the name of the title, right? Now, they've reused the same connection. So what I'm going to do is just change this to use the other one. That was overloaded. There was another get title that would just open a new connection. Okay. Now, obviously, a better fix would be to go back to the original query to put the title in it. Okay. And I think I've already done that actually. So a better fix would have been to just. I think one of the parameters in the query I changed so it actually would have the title in there in the first place. Okay, so that should fix that problem. Now when we go to log in, it should work. Oops. So now, obviously the do we need that now? Right, so now we don't need that, I don't think. Try that again. Okay. Let's try a test harness now. See how we're doing. Okay, so we've gotten rid of the Mars, and what we're hoping is that will get rid of the async network I/O for us. Now, it wasn't the Mars itself that was causing the async network I/O, it's the fact they were consuming one sort of data reader while going away to actually do something else. As it happens, that something else was a second actually data reader, but it could have been something completely different, right? So you see here we're up to 3,000 orders per minute, and if we leave it running, it might get a little bit faster. There's 3,100, and so forth. If I scroll down, I can see that's 3,100, and our latency is at about 350. So that might go to 3,200 if we leave it for a little while longer. So that's not bad. Now, the next problem we're going to look to fix, if we look through these perfmon counters, something that we probably should have fixed at the very start is the processor utilization. I'm assuming that's not good, right? That's at 100%. And this often goes hand in hand with lack of parameterization, okay? Because the extra effort to for SQL Server to compute the plan for every single query is going to cause the CPU to go through the roof, right? So it's a no-brainer that if you see the compilations per second being high and CPU being high, you need to stop at that point. I mean, this probably should have been the first thing that we fixed, okay? As it happens, we're going to leave it there. So not bad. I mean, we started off at 650 orders per minute. We're now at, what was that, 3,200, and we're at about 300 milliseconds response time. So what I'm going to do now is fix that problem. So to fix that problem, first of all, I'm going to stop my test harness, go into the code. What I've done is I've implemented different types of business layers. So the one that we're currently using is called ad hoc chatty. So it's just firing ad hoc SQL, and it's very chatty, like there's lots and lots of ad hoc SQL. So the one that I'm going to use now is I'm now going to use parameterized. And the difference is, if you look at, So what the parameterized is going to do is it's using the exact same strings, but what we've done is where they had a literal before, and they were probably using the string.format function to put in strings into the query, we're now just using an @ symbol. And then what we're doing is then obviously using a parameter, a proper OLEDB parameter that will get passed down with the query. So if you look at the before and after, let's just take a simple function such as get title, okay? Select title from products where product A equals, that's our refactored one. If we look at the original one, you can see it's using string.format, so it's actually sending down the actual string itself. So the change to do this was pretty straightforward. All I did is I just put an @ there and slightly changed it round. And then what I've got is, this is using, when we create the logic, we go through this thing called a factory. So what happens, the application will say, I want to create an instance of the business logic, and depending on what it's set for, it can pick a slightly different flavor. So we're using flavor number -1, and we're going to switch to flavor number 1. So I've just got a little config setting that I can change that in. Okay, now I'm not going to rewrite all the code here. I'm just going to now run that. And let's see the impact that has. And you also should be able to see the impact on the profiler trace as well. I'll run profiler. So we should now see parameterized SQL, like sort of stuff that we expect to see. There we go. Okay, so we can see here we're actually getting SPXQXL, getting all the parameters back. That's nicely parameterized SQL. Now, how does that affect us from a performance point of view? We can see we're now up to 9,000 orders per minute. Okay, no, sorry, 10,000 orders per minute. But look at the CPU. Okay, it's still pegged, right? Let's just make sure we're not running profiler trace. Yeah, okay. So we're seeing SQL Server is consuming 30%. Actually, the web application is starting to consume a lot more on the box there as well. So although the CPU's at 100%, SQL Server isn't actually consuming more than 40 to 50% of the box there. But the key point is, if you look at the parameters per second, compilations per second are now tiny compared to the batch requests. I think if you look at any of the rules that the Microsoft customer support give out, there's a spreadsheet they have that we actually got hold of, and there's a list of rules and the thresholds. The general recommendation is that compilations per sec should be 1% or less than your batch requests per second. So we can see here that it's, 0 would be nice. So we'd have to profile our SQL to see which isn't coming down as parameterized and fix it. But the percentage there is quite acceptable. And we're up to about 13,000. So you can see we probably should have made that change first, right? Parameterization, 13,000, because that's a huge change, yeah. So if our goal was to try and get up to 100,000, where that's put us quite a bit of the way from where we first started there. Okay, so let's look at what we can do next. So we got rid of our Mars, we've got rid of our parameterization, and what we're going to do now is address the chattiness, right? If you look, now I haven't run Visual Studio Performance Analyzer that I showed you at the start, but if you remember when I first showed you there was a screen called tier interactions, and it showed you how long it had spent in each of the tiers, right? Well, one thing that's quite interesting, and this is a warning sign, is if you look at the counts in Visual Studio Profiler, when we profile it from Visual Studio, we can see that when you purchase, there's 8,000 purchase requests, right? But the number of queries that generated was 191,000, right? So that's an anti-pattern for chattiness, because each of those queries is a round trip. Now, the latency might only be a millisecond or two, but add that up to 191,000 times, and, that's a considerable overhead, right? And this is where we come to the debate of should you write stored procedures or should you not write stored procedures, right? The argument on stored procedures, there's a lot of design-related things, but for us, from a pure performance perspective, it's not about parameterization, because as you see, we can parameterize all the SQL without using stored procedures. It's about reducing the chattiness. So that's why I would recommend trying stored procedures here, because what we'd be looking to do is to drive the ratio of number of queries to number of requests closer. No, I'm not saying a one for one, but a 2 for 1 or a 3 for 1, but not a 50 to 1, right? That's the sort of ratio that we're actually looking at. So how much faster would this workload be if we use stored procedures? So that's currently running 13,000. What we have is another number 2. Yeah.
So I'm playing the devil's advocate. For example, if you were to say, okay, we only use stored procedures, and you tell all that's all you tell the developers, and they're going to write one stored procedure for each of these types of queries.
Yeah, yeah. A key thing is we're not saying to use stored procedures for stored procedures' sake. We're saying that we need to reduce the number of queries going between the client and the server. If the developers took every statement and wrapped in a stored procedure so we still had the same number of calls, it would be pointless, right? Now, I actually had another customer. Sorry?
Depends a little bit on the size of the queries.
Yeah. But it might help a little bit, but it wouldn't reduce our core problem here. It would be less network bandwidth because the strings are smaller, right? But that's not going to. We'd barely be able to measure that improvement here. What we need is to get them refactored so that multiple statements are executed with a single call. Now, I actually found a customer that did something that was fantastically clever just to try and defeat me. I told him that he had to get fewer conversations, and what he did is he got the dynamic SQL, put a semicolon on the end, manually called SPXecute, and concatenated 10 of them at once in the app tier, and then fired a string down. So what happened is he did comply with what I was looking for, but something else very unexpected happened, is that if you look here, you'll see all these are RPC calls, right? And what he did is when he tried to shrink it by sending multiple statements with a semicolon, what happens is he had to send it as a command type text in ADO.next. And our compiles per second went through the roof on the server. But when we looked at the profiler trace, all we saw is SPXecute SQL with correct parameterization. So we knew his workload was parameterization, yet the compiles per second went through the roof. The reason for that was, if you don't see RPC, if that says batch and you see that, SQL Server has to take that string and compile that string to separate all the individual one. So it's a compile, but it's not a compile of a query. It's a compile of the string to separate all the queries out of it. And that had an adverse effect on the CPU. So all of the clever things he tried to get away from writing stored procedures didn't actually help. So I'm going to rewrite this as the stored procedures, but the bottom line is stored procedures won't always help, right? If you can't logically bundle multiple statements up, then your performance gain from writing stored procedures might not be as much as you'd hope, in which case, kind of why bother, right? But I'm just going to try it in this case because the purchasing, we've specifically identified the purchasing as being very heavy. So what you could do is find specific components. If you look at that tier stack, I can see per function call what the ratio of queries to function call to focus on just one aspect and find the heavy hitting one first. So we look at the source code for purchasing. Go the way back home.
And also, I would like to say, well, one of your clients did something which was very silly. But if you were actually bundle all of your small queries into sort of, well, rather than putting them into procedure, you would put them into the client code. Well, parametrized is one single batch.
Yeah.
Well, you would get the same effect. Now, of course, there might be other reasons, but I'm sort of just trying to get to the point where, because of course, you would send large queries out, so you would get more network overhead. But just trying to press what are the keys when you use the procedure. It's just
Yeah. So, and it can be quite a philosophical debate as well, because a lot of stored procedure debates comes around the design practices of stored procedures. People get scared because they think you're putting logic into the sort of data tier, even though it's only data-related stuff and stuff like that. Just to show you the difference it makes here, I'm going to do this as a stored procedure. Now, why did we have it as a stored procedure? If you look at the original one, you can see what it's doing. Like, it's beginning a transaction outside of the SQL engine, which in itself is a client server trip. Yeah, it's then there's one statement it's executing here, there's another statement it's executing here, there's then a loop. There's a while loop, and then it's executing individual inserts inside the while loop as well. So you can see that if they order lots of things, you're suddenly going to get 20, 30, 40 statements. So this is a good hit for rewriting a stored procedure, because if we look at the stored procedure version, we go from that code base to that code base. Yeah, so it's, so let's actually see how that runs. Like, what sort of difference does it make? Is the performance different worth the, investment? So now, rather than seeing all these SPXecute XL, what I'll now see, hopefully, is just stored procedure calls. There you go. Let's see, login, browse. Hopefully, there should be a purchase there somewhere. Is anyone buying? Yeah. Okay, it's coming up. Yeah, okay, I saw a few there. There. So there's my purchase now, right? So whereas previously that would have been 50 or 60 individual statements, it's now just one function call. And now it'll take a while. As it happens, in this case, the difference that it makes, when I tested this, going slightly different hardware, it went from 11,000 to 13,600. So not a huge gain. Look, if you look at the parameterization, we're going from 3,800 to 13,000. I mean, that's like a 5x gain. Converting it to stored procedures, only gave us a little bit of a gain. Now, I don't know how far it's going to go. We'll have to wait. But I'm guessing in this, it might go to 14,500 in our little test harness here. It seems to be running a bit faster on this one, right? So percentage-wise, you're looking at, what's that, 10%? Okay. Now, just to be clear, the reason it's only 10% is because I'm all running off the one box. There's no network, right? If this was the ultimate example of something in the cloud, where there is a distance between your SQL Server and your app tier, that gain would be much, much larger because you're cutting out network round trips. So the value of stored procedures is often dictated by the type of application. If it's all running on one box, you may only get a 5% gain or even less. If it's a large network running across a slow LAN or a WAN, it's going to be much, much larger gains, potentially a doubling or something like that. Okay, so now we're running with stored procedures. Let's have a look at what's slowing us down now. So we look at the wait stats. I'm just going to clear those. Run them again. Aha. Write log. Okay, so we're starting to hit the hardware limits now, right? So the insert queries are getting the write logs, and if we go to the exec requests,
Time to put your log on a separate drive.
yeah. Now, as it happens, I'm only running on sort of one SSD, so well, I do have a second SSD. I could kind of slip it over there, but yeah, you could potentially look at a hardware request there, like add more IOPS to the log drive, optimize it for sequential I/O as opposed to random I/O, all that sort of stuff there. So let's just see if we can see any waiting queries. They're all rating for write log. Okay, so we're going to take a different approach to make it faster. Rather than say what is slowing down my queries, we can flip back to the first way that we looked. Where's all my time going? Because if we sort out where all the time is going, both from the app stack and from the SQL Server queries, we can make it run faster. Yeah. Now, so although no one query is being particularly slowed down, time's going somewhere, right? So where's that time going? And unfortunately, the exec requests isn't going to help us here. It's only saying, yeah, I need a faster log, right? Which we could. So better way would be to go back to our RML that we looked at the first time. Now, I don't have time to run RML, so using this DMV here, the exec query stats, we can get a dump of the top queries that have been run. And quite interesting, these top two queries, look at the average time compared to all of the other queries, right? And there's two variations of them as well. So these have high execution count and they're the slowest queries as well. And this is because they're full text queries, right? Full text queries, not going to be the most performing type of query in the world, right? I'd expect to get more wait stats. You usually see full text queries appearing in exec requests with weird wait stats, like, so see that one there, preemptive OS generic IOPS. You know, that's because the full text has to make calls outside of the DB engine in order to do its work. And you might see mutex and stuff like that. So you can see that some of the wait stats it has recorded. Other ones we just know is taking a long time. I'm going to add another curveball. We go back to the Dell guys and we say, hey, great news. You're now running at 14,000 orders per minute. And they're like, that's great. By the way, we want to move into the cloud. Can we run this fast in the cloud, please? Right? So we're like, well, we're currently working on tuning. They go, well, while you're tuning, I want you to move it into the cloud, right? So we try moving our user database into the cloud. What's not supported in the cloud? Well, lots of stuff, but full text isn't supported. So we're going to look at other things that we can do why not make the application work harder, right? There's hundreds of implementations of full text that can use in-memory providers. If you're on SQL Azure, there's the NoSQL solutions. You know, a full text index isn't real time by its nature anyway, right? So you don't have to use SQL technologies. So we're seeing we make it faster by offloading the work to the app tier. So offloading work from the SQL to the app tier can be a good thing to do, because ultimately you can scale out your app tier. So if you can transfer time spent in a database engine for CPU on the app tier, that's generally going to make it go faster, right? So what I did is, on a first attempt, I said, hey, can't be that hard. I'm going to write my own full text engine. And I won't lie and tell you it worked perfectly well first time. So what I'm going to do now is start to cache some of the data. So what I've got is I've got a module I wrote that basically takes the commonly used tables, so it's a products table, and creates a snapshot of that when the web application starts. So when the web application starts, it's going to create, so it's got a class to store all of the products in, and it's then going to create a hash table for that, also a dictionary object, and it's going to put that in the cache of the web server. Now, there's products that would do this much, much better. So a lot of our customers will use the like of memcached, or if you're in the, or if you're using Azure, it's now got its distributed kind of in-memory caching actually technology. I only did it this way because I had about half an hour to get something to work, right? So let's actually see what happens when we turn that on. So, and I didn't worry about the concept of staleness, but yeah, you have the problem anytime you implement some sort of caching, you've got the concept of how do I handle staleness, and if you're caching records that are changed, how do I cache when a change happens? So certain products have that sort of technology built in. If you're rolling your own in ADO.NET, you could use sort of query notification as a way to refresh your actual cache. I haven't implemented it here because I just want to see the performance difference it makes. But there is a lot more than just writing the code to bring it up, because you've now got to add all the management overhead of that. Okay, so let's implement that now, right? So this is number 3. So I'm going to go to here, number 3. And then in my first cut, what I did is when you look for an actor, I just go through the in-memory cache and I loop through them until I find one that contains the relevant thing I'm looking for, right? So it's all going to be in memory. There's no hit on the SQL server. So I won't see those stored procs come down. That's all been now done in the app tier. So let's do that and see the effect on performance. Okay, that's just launching. Hopefully it won't crash. Okay, not so good. I'm now down to, I was at 14,500 orders per minute. I'm now at 800 orders per minute. So who said I could write a better full text engine than Microsoft? So if, and we probably don't have time, but if we were to run the Visual Studio, that first option by CPU, we'd see where all the CPU went, yeah? And the problem is, there's so many, there's about 100,000 products. So to loop through every single row and do like a contains, you know, for every single one is incredibly CPU intensive. So much so that it's now consuming all of the CPU on my app tier. So in my attempt to make things faster, I've actually made them slower. So what I did then is I had 2 options. One, actually go out and buy a proper full text product. So a Lucerne have one that works like outside the DB engine, and there's various other providers. Or what I then did is I wrote an optimized version. So what I did is, as I cached the records, I built another in-memory cache of which words could be found where. So I now only had the equivalent of an index lookup in a .NET class to find it. So it was an optimized version. So let's run that version. So just to be clear on what the optimized version does, what I did is I created an extra sort of cache element called actor index that basically stores which products an actor was in, so that I can retrieve that now with a minimum number of iterations rather than having to loop through the entire table, which is equivalent of a table scan, but it's been done in memory. Now it's going to be much, much faster. And let's see what that does. Now, obviously what's going to happen though is my first call, as soon as the application starts, it's obviously got to cache all that stuff. So my first call, when the application starts, is going to have a few seconds delay while it puts all that stuff in memory. But after that, I don't have to hit the SQL Server database for anything. So you see, I'm now up to 16,000, might even go even higher, right? So if we leave it there for a little while, okay? So what you can see there, I took some of the weight stats that we got. So you see select star from products where contains, we got this weight stat, FT, IFTS row lock, and a few other weight stats happening as well. But more importantly, from a time perspective, we could see that nearly 50% of our time our SQL Server was running full text queries. And even though it was running them efficiently, they weren't actually waiting. It was still taking a long time. So what we've done is we've cut those out. Okay, so what we've got now is the data cache version. So that's 16,000 or so. Okay, so it might even be 60.5. You see, it's a gain, but not a huge gain. FTS. Now, but the nice thing about is we could now run this on SQL Azure if we wanted to, assuming the table of clustered indexes and everything else. We could actually port that over to SQL Azure, and I do actually have a copy of this actually running on a SQL Azure database. So if we get time, I can actually show you that running against a cloud-based database as well. Okay, so let's repeat the process now. If we go back to and look at our wait stats and look at our exec requests, we can see how could we possibly make it go faster again. So we've got a write log. Oh, we're starting 3% of our awaits are kind of latching. And as we were discussing kind of later on, when most of your waits are latching is an indication that you've started to reach the limits of the product. Now, there's ways of getting around that, but it's a good sign, right? Well, it might not be a good sign if it's just ceiling and you want to go a lot further, but it's a good sign from an optimization of the workload point of view. Where is most of our time being spent now? I'm just going to free the pot cache and see where the time's been spent. Okay, right, so we see there's some select statements and we're getting a high execution count on some of our select statements and stuff like that. So what I then tried to do is I followed the thread to say, well, why don't we, there's a lot of reads here where they're just to run profiler. That's why we've still got a couple of... So there's a lot of selects based on the products, but in order to build the full text engine, we had to put the products table in memory. So we could cut out all of those all those piddly little reference lookups and everything else that the application is having to do. We don't need to go to the database engine to actually do those. We could reuse the cache in order to get those. So what I did is I'm now offloading reads of reference tables to the application tier to see the difference it's going to have on the performance. So let's actually do that. So I've got one here, and what we do is if we want to get the product actually details. Now, one of the challenges I had is that original application was obviously assuming there was a SQL query. So it was consuming a data table or a data reader. I didn't have time to rewrite the GUI because the GUI was still consuming out your data table. So what I did, my internal objects put the in-memory stuff into a data table, pass it back to the client so that I didn't have to rewrite any of the client, right? Obviously, ultimately, you'll find the cost of using data tables is a lot more expensive than you'd think. If you run the code profiler, you eventually reach a point where the cost of creating temporary data tables in memory is quite expensive and is a sizable percentage of your workload. As it happens, I just actually did this because you can see how there's a natural path. Client consuming SQL Server queries using a data table, client consuming in-memory using a data table, client consuming a class using in-memory component. So there's a natural upgrade there, and I only upgraded one of them. But let's actually, so let's run that version. Go. And see where we're at. Come on. 15,000. Wait for the controller to kick in. Oh. Hope that kick in. So what we should see there is quite an increase in. I'll have to worry about that later. Let's go back to here. Try that again. Do you want to see the increase that we get there? So the concept there is I'm taking the little reference queries that are coming from the in-memory table anyway and just running them pure in-memory to see what sort of gain I get in terms of percentage workload. Now, come on, 11, 13, 14, 15, might go up to about 16, 17,000 maybe, 16. Okay, let's kind of leave that running and let's move on. Okay, so I think we're at about 17,000, and I just want to show you, apart from the tuning, what else we might want to do. Now, it might reach a point where we decide to throw more hardware at it. So because it's running on a VM, I could shut down the VM and I could change the number of CPUs, okay? Now, I'm not actually going to do that because it takes me a few minutes to actually do that, right? We see we're now at about, I think we're currently running at about 18,000. About 18,000, which isn't bad from our original 18,000. That's with data caching, okay? Now, I'm not going to have time to show you all the results, but what I've done is I'm going to give you here's some I prepared earlier, all right? Where's it gone? This is all the different flavors, right? And what I found is when I implemented this is on my version back home, starts about the same. When I got rid of the full text, you'll see that it went from about 21,000 to about 30,000. So that full text, even though there wasn't anything wrong with it, like it wasn't causing any waste, it was just taking so long that it was slowing down the whole workload. By moving that into the app tier I went from 21,000 orders per minute to 30,000. By adding the reference tables, I got it to 35,000. So I got an extra, I got a fair whack of a gain there by taking all the reference tables. I then actually I took that exact same workload and I ran it on a SQL Azure database. So I effectively got, I put the web server in the cloud and then I put a normal SQL Server account. Obviously, I'd remove the full text and everything else, and I got about 14,000 orders per minute. So that's quite interesting because that gives you an estimation as to the type of hardware and capability of the Azure. You can see that on my laptop, I could go to about 35,000, but I'm running an SSD, I'm running 8 cores, you know. So you can see the sort of capability that you've got on Azure is probably about half my sort of performance laptop. So it's not bad, right? And that would be your building block. If you wanted to scale this in Azure, what you then need to do is federate it. So what that would mean is creating multiple user databases and in the app tier directing different customers to different user databases, either using the native federation that's built in to Azure or rolling your own. There's lots of examples on Codeplex on how to do that. But a key point is you're going to get between 10 and 14,000 orders per minute per Azure database that you have, and you now have a blueprint. The last thing that I did that had quite a dramatic effect is I rewrote the purchasing stored procedure, okay? And it went from 35,000 to 45,000. What I did there, I'll just show you this. Where's my... if you look at the procedure, if you're used to refactoring stored procedures, you'd immediately see, you know, there's some gain to be had here. You see this while loop, they're looping through all the products they bought, firing individual update and individual insert statements. So what I did is I created, unfortunately I had to create a temporary table, inserted the 5 or 10 items into a temporary table, and then did the whole workload in one set, yeah? And that then meant there was a reduction in the chattiness because there were less individual SQL Server statements going to the DB engine, much larger ones, which is, I think, is really what the product prefers, to have a smaller number of larger statements than lots and lots of small statements. So that change by itself had a fairly good improvement there. And then we finally hit the latching problem. Because they're clustered keys, parallel inserts into clustering keys don't work very well. So I converted them to hash tables. The SQL Cat team have a white paper that we chat about outside, I think, called How to Resolve Latch Contention. There's also styles of partitioning that will help fix latch contention as well. So we managed to, on a single box, just a single modest box like my laptop, we got that up to 47,000 orders per minute. If you see from the starting point of 600 orders per minute, you know, that's not bad. That's a 7,700% increase or whatever. So you can see the sort of changes that we made where you've got to change parts of the .NET application to make that happen, okay? So we've kind of run out of time. I did want to show you some stuff running in Azure, but you'd have to close your eyes and imagine it, right? So we'll break there for any questions now, yeah? Yeah?
One more conversation idea for the purchase thing was, because you're sending down a bunch of variables for all these projects. Of course you would send a table variable parameter.
So that's actually quite interesting because one of the first things I tried is sending down a table value parameter, right? And we hit a problem in that we got contention on the tempDB on the table variables. So they actually caused a little bit of contention there, and that actually caused a slowdown in the workload. So I ended up using a temporary table using a temporary table inside the stored proc. I still got a bit of contention on that. I haven't got time to actually show you there. So I've still left with, once we got that optimized version there that did 47,000, actually 30% of our weights were latches on temp objects caused by the thing that we're done to go from the while loop into inserting into a temporary variable. And a table variable didn't actually help us that much, unfortunately. But they are super useful, though. So there's still room for optimization there.
One thing I see, you didn't have that many variables, but one thing I've noticed, I did some tests, is that if you have lots of variables, like 2,000, there's quite an overhead sitting down that many parameters.
Yeah, yeah, yeah. So there's a test that we have, which is where we insert about 1 million things using either a TVP or using a SQL bulk as your copy. And the key question is, when do you invest the extra effort in using a SQL bulk copy versus when do you use a table value? And we found that for a few thousand and under, the table value parameter worked out quite well. But as you start to scale up volume, using the SQL bulk copy class for just inserting lots of things worked much, much better. Okay, any? So I'm hoping this is food for thought, yeah? Yeah, so one of the most frequently requested things is, I've got a few different versions of the actual data access. Could I rewrite basically one of those in some of the ORM versions? And that's work in progress. A key thing is that when you use an ORM, what you'll see from the SQL perspective is parameterized SQL. So what you should see is, do you see the second version of mine had the parameterized SQL? You should see a similar performance profile to the parameterized SQL. So not as high performing as the stored proc one, but bear in mind the stored proc didn't give you that much gain. I mean, what did we get? We went from 13,000 to 14,500. So I would expect an ORM to be roughly like that. The difference is, if you use an ORM, you'll get a higher CPU hit on your app server. So if you've got CPU to burn on the app server, it would probably work out well. But one thing I'm working on for the next version of this is to also have an ORM version of the library as well, because that would be very interesting to see where that fits in. But if we do have a customer that has an ORM, we don't instantly tell them to not use it. We just really look at the profile of the SQL coming out of that to see where it's spending most of its time. No. The general guidance on ORMs is they do obviously help with sort of prototyping and stuff like that. You will reach a point though where it becomes more efficient to write a stored procedure. So if you're doing very complex work, you're going to want to write a stored procedure. Now the newer ORMs also let you use stored procedures, so you convert it into a method call within the ORM. So the guidance that we would give is use something like RML or the Visual Studio Performance Profiler to see which part of the workload is spending the most time, and if that's one of the ORM calls that can't be optimized by just, for example, indexing or something as simple as that, and you might want to upgrade that particular part of the ORM to use a stored procedure. But the key thing is, don't upgrade all of the ORM code to stored procedures, just one or two key components where it's spending most of its time. Does that make sense? But it can be a problem from a tuner's perspective, because obviously the ORM is generating the T-SQL, so you've got less flexibility. But you can still obviously do indexing and stuff like that. Cool. Okay, hopefully this was food for thought anyway. So it's sort of, it's always interesting to kind of try and cross at the app and the SQL tier to see where there's a problem that can be fixed by either end of the solution. So hopefully that's worthwhile.
Any last final questions, or all happy? Oh, okay, thank you very much, Bob.
Thanks.
Yeah.